And I'm back. So here is what a graph looks like. So it's weird. You have the number of mils of added sodium hydroxide to 50 milliliters of 0.1 molar HCl. So you have 50 milliliters of 0.1 molar HCl in like a beaker or something, and you're adding slowly 0.1 molar sodium hydroxide. So the same concentration of HCl and sodium hydroxide. And notice the pH is barely moving as you add 10 mils, 20 mils. It's changing a little. And there's pH on the y-axis. But then when you get right around 50, it starts zooming up like crazy. And it ends, the equivalence point is right here at pH 7. And that makes sense because it's a strong acid and a strong base. What's also kind of interesting is that, well, it takes exactly 50 milliliters of 0.1 molar NaOH to neutralize 50 milliliters of 0.1 molar HCl. Maybe that makes sense because you have the same volume, same concentration. So it should be the same. It should be 50. It was 50 of 0.1 and you have 0.1. It should take 50 of that to neutralize. And that's exactly what happens. So look at the x-axis above. What volume of 0.1 molar NaOH was necessary to neutralize 50 milliliters of 0.1 molar HCl? The answer is 50.00 milliliters. You can tell because it is that steepest point right here. What if instead we had 100 milliliters of 0.1 molar HCl? So instead of 50, we had 100. How many milliliters of NaOH do you think that it would have taken to neutralize 100 milliliters of 0.1 molar HCl? Good. Fill that in right there. Now, here's like the bonus question. If you can get this, that's awesome. If you can't, it's not a big deal. What if instead, you still need to write an answer down, okay? So you can't get credit for your homework without writing an answer down here, too. What if instead of having 0.1 molar NaOH, I had 0.05 molar NaOH, so less concentrated NaOH, and I had my 50 milliliters of 0.1 molar HCl. And let's write that in. With 50, back to the original 50 milliliters of 0.1 molar HCl. What would I need then? It'd be a little bit different too. So now instead of having the same concentration, this is only half as concentrated. So will I need more of it, less of it? How will that work? Think about it. And at the equivalence point, the bottom line is always that the number of moles of acid equal the number of moles of base. Every time. We have a formula. It's on the back of the reference table. MAVA equals V, and that is what we're going to start with in class once we go over some of the stuff that you've done. But it's a very simple equation to put in, and it allows us to calculate the equivalence point. And that's kind of it. So you've learned the basics of the essentials of neutralization and titration. We're going to go over the rest of this in class. I'm now scrolling back to the top. That's page 17. So you should have 17 done, 18 done, and 19 filled out. We're going to go over it as well. And then we'll do 20 and 21, and then that's it. So thanks so much for watching, and I'll see you tomorrow.